Okay, so we are going to start our unit in organic chemistry. We're going to be looking at covalent compounds. So there are really millions and millions of contained organic molecules. So we have a whole variety of things that we encounter in our daily lives that have this. So all of this stems from one thing, and that is carbon. Carbon is what we call tetravalent. That means it can bond up to 4 times. It's one of the few elements that can form chains with itself, and it can form what's called a branched network, and it can form rings. So when we look at organic molecules, most of them will have no charge. Most of them will contain carbon-carbon bonds and carbon-hydrogen bonds, which are nonpolar. For example, water, which has a slight charge, is what we call polar. Because of the nonpolar nature of most organic molecules, they will not dissolve in water. For example, oil and water are not going to mix. So most organic molecules are gases. They're quickly evaporating liquids at room temperature. Because of the no charge, they have what's called weak physical bonds through those London dispersion bonds. These organic molecules are not going to have a charge unless there's a bond that has polarity. If they do have slightly charged bonds, like a carbon bonds with an oxygen or an oxygen bonds with a hydrogen, as in what happens with some of the alcohols, they will dissolve well in water. So, for example, methanol will have a slight charge. It is a liquid. It will dissolve in water. Methane gas, no charge, will not do so. There is no attraction between it and water, unlike methanol. So when we start looking at our hydrocarbons are hydrogen and carbon bonds. There are a few different branches of this that we are going to look at. There's what we call the functional groups. Those are our altered hydrocarbons. That would be the ester, the ether, the aldehyde, the ketone, the carbolic acid, alcohol. There's the aromatic. That would be your hydrocarbons. Those contain benzene. And then there's the aliphatic. Those are the hydrocarbons, the chains of carbons and hydrogens. So in those, there are 3 types. There's the alkanes, which are only all single bonds. There's the alkenes, which have some double bonds. And there's the alkynes, which have some triple bonds. So that leads us to the conversation of saturated versus unsaturated. We're going to get there. So when we're talking about the aliphatic hydrocarbons, these are the hydrocarbons that are compounds composed of carbon and hydrogen. They come in chains. Their name actually literally means chains of carbons. They're either going to be straight or they're going to be branched chains. So if they are saturated, then they are all single bonds. They're carbon-carbon single bonds. If they're unsaturated, that means that there is a double or a triple bond. So these are their common hydrocarbon types. There's the alkanes, where there's only single bonds. We have a chain and we have a branch structure here. There's the alkenes, which have at least one double bond. And there's the alkynes, which have at least one triple bond. So again, there's a chain structure and a branch structure shown here. So the structural formulas are going to show us the structure of the atom. That's going to be the unbranched or the linear or the branched. There are then condensed structural formula, which show us what happens when they combine. So we're not showing these individual bonds between the carbons. There's some bonds shown, but not all of them. And then there's the molecular formula. The molecular formula tells me nothing about the structure, just tells me how many of each thing we're dealing with. If we look at the condensed notation for alkenes and alkynes, one thing to note is that we show the location of that double or triple bond. We show that notation of where that double and triple bond is in that condensed notation. So even our really complicated branch structures can be written on a single line. So that makes it pretty easy. So a lot of handbooks are going to use a condensed notation. So if we have an alkane, we just write it like this. You'll notice that the branches that pop up are grouped in parentheses. They are shows that they are attached to the carbon atom that they follow. So that's where you show the branched pieces. So this is one form of our notation. There is also what we call skeletal notation, where we are just showing the bonds. We are not showing the individual atoms. And that's what this is. So this is showing those individual single bonds. Here's our double bond, our triple bond. So the other bonds just are not shown. We're just showing the bonds between the carbons. And we're depicting those double and single bonds, even the triple bonds.